Oh, yeah. I know you're excited about this one. You're excited about all of them. What am I talking about? But go on. You've been excited about this one for a while. Who have we got?
All right. So our next speaker is a DJ, but we didn't have him come on to be on the turntable. Actually, he's the technical advisor to the CTO of HashiCorp. And I'm so excited about this because we use HashiCorp here at GitHub. So I'm really excited to hear what he has to say. The name of his talk is Collaborative Application and Infrastructure Workflow Using GitHub Actions and HashiCorp Terraform. Please help me introduce the one and only Mishra.
Mishra!
I apologize, my mic was muted. So hello, everyone. So yeah, really appreciate having me at the conference. This is one of the conferences I've look forward to presenting at for a while now. So should be an exciting talk. So today I'm going to be presenting collaborative application and infrastructure workflow using GitHub Actions and HashiCorp Terraform. So it's kind of a talk about how GitHub Actions and HashiCorp Terraform work together, and we'll talk about a few workflows. Talk about the industry shift and things like that. So my name is Mishra. I'm the technical advisor to the CTO at HashiCorp. But my background is in computer engineering. So I've done a bunch of operation engineering work. I've also done software engineering work. So I empathize with both operators and developers, and I know it's not easy to ship software today. So a lot of empathy towards both sides here. Now, as a technical advisor to the CTO, I work on a few strategic projects for HashiCorp. I span all of our open source projects. It's an exciting gig. So in terms of open source, I've contributed and created a few projects. One of them is Atlantis, which helps you kind of collaborate on infrastructure using Terraform. And then I'm also a provider maintainer for Virtual Kubelet. I've more recently gotten into the new projects that have come out from Microsoft open source. One of them is Dapper, which allows you to kind of build distributed applications. I've contributed a few things there. But the most exciting part of my job, in the past 2 years, has been creating a podcast called HashiCast. I co-host that with a bunch of folks at HashiCorp Developer Advocacy team. So, okay, a bit about HashiCorp. For those who don't know about the company, we're a cloud infrastructure automation company. We focus on 4 different areas: provisioning, securing applications, connecting them, and then running them at scale. In terms of the company, we were founded in 2012 by Mitchell Hashimoto and Arman Dadkar. So it's been a bit, a couple of years, exciting years. And then in terms of employees, we have 900 plus employees. We are almost fully remote. And we work on these 6 open source projects that are free to use, free to download, very proudly hosted on GitHub. So I'll kind of give a quick intro into kind of each one of these tools. And I think we'll only focus on Terraform for this talk. So I'll start from the lower left. So we have Vagrant, which is a developer environments tool, helps you create developer environments, share them. We have Packer, which is a server imaging tool. It helps you kind of create server images on-prem, cloud. We have Terraform, which is an infrastructure as code tool. You can write things in plain text files and make them happen. This is the kind of the focus of the talk. And then we have Vault, which is a secrets management tool. Helps you kind of manage secrets in one place. It kind of helps you with that crazy secret sprawl that we see in our data centers. And then we have Console, which is a distributed service mesh. Kind of helps you connect applications securely and gives you that L7 routing and canary deployments and things like that. And then we have Nomad, which is a general purpose cluster scheduler, very in line with Kubernetes, but it can actually schedule containerized and non-containerized applications and even VMs if you like. So that was a bit about HashiCorp. So kind of taking a step back before we get into GitHub Actions and Terraform, kind of take a look at what is happening in the industry, right? Like the HashiCorp view, right? Which is there is this transition into DevOps, and the big change that's happening is we're going from this traditional data center approach in which you had hardware, you have to manage networking, cooling, rack them up, figure out power, into things like the public cloud, right? We have the modern data center approach in which things are dynamic in nature. They can come up and down, and you can just sign up for a cloud provider account, and you get access to amazing compute. You can scale up applications. fairly easily. So this is the big change, right? In terms of process, we're going from this like very ticket-driven approach in which you had to create tickets and then work on them, and then wait for hardware, wait for like the teams to align behind them, into this idea of like DevOps, right? Use the DevOps philosophy to kind of do things which drive systems that are API driven and give you like that self-service. So why are we, why this shift? Like, what is the thing? There's many reasons for this, but one of the critical reasons is increasing developer velocity, which is how fast can we ship to production? How fast can we ship a feature to production? Kind of empower the developers and kind of make an efficient use, and you kind of make the time to value very efficient. And what helps you achieve this? This is the kind of the DevOps philosophy, right? You have your core teams like operations, platform teams, security teams kind of build APIs that the developers could use. All right, so this is where we kind of introduce Terraform. And when we talk about APIs, talk about making things happen, we introduce HashiCorp Terraform, which is free to use, free to download. And the primary goal of Terraform is to kind of provide you with this unified workflow using infrastructure as code. So that's the core of the product. And the idea here is to kind of have, you write plain text files and make them happen, and use the same software engineering philosophy that we've been using for a while and pull that into infrastructure, right? Like, and use it to like version infrastructure and kind of iterate over it safely. The idea here is to go from one stage to the other in a kind of a safe manner. So from nothing to something, and maybe day one, day two operations. And then the key thing here is we want to be provisioning anything anywhere. And when I mean anything anywhere, I literally mean it. Like on-prem, cloud, DNS providers, CDN providers. If you have an API that can do CRUD operations, you should be able to work on them using Terraform. So how does provisioning work with Terraform? So you have the Terraform core and Terraform provider. So as a user, what you see is, you just download this binary and you can use it. But in real life, there is the Terraform core that is responsible for operations like, parsing the config file, and doing things like state management and stuff like that. And it doesn't really know about like the implementation details of the provider, which is like, how to manage a server and so on. And then the providers are the ones that actually make the API calls to Amazon, GitHub, and Kubernetes, and so on. We have 200 plus providers that are open sourced and are built on top of the open source model. We have 1,200 plus contributors that actually maintain and help us kind of drive that ecosystem, which is pretty cool. So one of my favorite examples is to use GitHub, to use Terraform to manage GitHub, which is kind of meta in this case. So even at HashiCorp, what we do is we create repositories, we manage permissions, all using Terraform, and kind of provide this like really simple HCL language where you can write like what you want. So in this case, we are creating a repository and maybe assigning a certain role to a member, right? Fairly easy. So a typical workflow for a Terraform user is like for a single user, maybe a smaller team, is as a developer and operator, you just download the binary and you write some Terraform. And the first thing you run is something called the Terraform plan that helps you preview what's going to happen before it actually happens. So in this case, you can see we are adding one GitHub repository, and we are able to kind of preview things. This is just a read-only operation. It doesn't really do anything. And this is how you kind of safely iterate over infrastructure. So in this case, you see now we can actually, if this plan looks good to you, you can go ahead and apply it. And you can use the plan as in an input for the apply, and only that plan will be executed. This is where Terraform kind of gives you that guarantee that, only the change that you want to go out will go out. And if in real life something changed, for example, like someone went to the Amazon console or GitHub UI and created something which conflicts with this plan, then this apply will safely fail and you don't get your resource, which is what we want in the kind of the reality, right? And if everything works, you get your Amazon server, you get your Kubernetes pod, or you get your GitHub repository. And all of this happens using the CLI as well on your computer. This is for like a one user, maybe a smaller team. So how does collaboration work with Terraform? So this is where kind of the whole DevOps philosophy comes into play. So let's say a developer joins an organization. They can create a bunch of HCL and say, hey, I want this role for this repo or something like that. Request for GitHub access. You have an operations team that can actually review the plan, let's say, and then give them access if that looks good to them. This is how you can onboard users if you like, which is pretty interesting. And this is what we do at HashiCorp as well internally. So that was the workflow that you saw, which is basically the basic workflow that works for a smaller team and maybe a group of, a smaller team, or like maybe an individual or two people, kind of just, where you have to coordinate a lot of changes and things like that. So how does, the larger organizations with many teams work with Terraform? So this is where GitHub can actually help, right? So we want to use the same, pull request, really nice GitHub workflow to achieve infrastructure and application changes as well. And we'll see how like actions comes into play as well. So let's say we have a developer asking for a VM or something, and they push certain HCL code up to GitHub. Then what can happen is a review can actually take place in GitHub, which will be generated using, maybe some CI system can actually run the Terraform plan and give you that plan output, and maybe an operations team can actually review the plan. If that looks good to them, they can actually make that thing happen for you. And then again, some system has to run Terraform apply, right? And ideally, we would want the whole thing to happen in the cloud. So this is an ideal situation. So this is where is like the perfect introduction, and most of you know where I'm going with this. I'm really happy to announce Terraform GitHub Actions 1.0 version, which is completely revamped. It uses the new JavaScript framework to make things happen. And I really want to thank the GitHub engineering team, the HashiCorp engineering team for working together. I'm just the face to this amazing collaboration. So here's a quick demo. I've recorded it for kind of time purposes. I don't have much time here, so I just recorded it. I love doing live demos, but unfortunately, this one's recorded, and it's fast forwarded in portions to save time. So here's what we'll kind of work on today in terms of the demo, right? This is the overall picture. We have an S3 bucket that's just hosting a static site. It has an index page. It has an error page. Then we have a Cloudflare DNS that's pointing to this S3 bucket. And both of these things are managed using Terraform. And we're using the new GitHub Terraform action to make things happen on the GitHub side. And we're using Terraform Cloud to do the kind of the remote actions and things like that. It's fairly straightforward, and you'll see how this all progresses. So here's the demo, right? Right. So this repo that you see here, it's already open source. I'll put a link to the repo at the end of the presentation. You can check it out yourself. It has all the code, all the things that you need to kind of make things happen. In this case, the HTML code and the Terraform code. So you can fork it and try it yourself if you like. So I've already cloned this repo. I can open Visual Studio Code and start working on this. So here I have the S3 bucket defined already that will host our website, which is public. And then I have my IAM policy set up to expose that bucket out to the internet. And then I also have a bucket object, which just is uploading the index.html file up to the S3 bucket. So here, for time, I've pre-provisioned it already. And this is all managed using Terraform. And you can see the index.html file that's already present. All right, so now let's say you're an operator. You want to create a DNS record that points to this bucket, right? So here we have the Cloudflare provider where you can manage, Cloudflare directly from, directly using CLI here. Directly using the HCL code. So what we'll do here is we'll add another entry. So here you can see that www entry that's pointing to that long S3 URL, which cannot be seen, and everything is proxied to Cloudflare. So what we'll do is we'll add another entry, which is for the subdomain to point to the www entry as well. So what we'll do is I just add another resource and basically use the buycoffee.app, which is our domain. You can check it out right now. It should be live. So in this case, we'll create the subdomain that points to the www domain, right? And we are providing it with Cloudflare, zone ID and email API keys. Now, if you're an operator, you have the keys to the kingdom. You can pretty much run a Terraform plan. You have the Cloudflare API keys. You have the AWS, API keys. So you can pretty much run Terraform plan, and this will work, right? Like as a sole operator, have the keys to the kingdom. So this is Terraform Cloud that's running the Terraform plan here. So you see, we are adding that one resource. But ideally, you want to share this with your team, right? You want this to happen in a collaborative way. So how would that work? So that's where you use the GitHub action. This is the Terraform GitHub action where you can see there's different steps defined. It's called Setup Terraform. This is already published in the marketplace. And you can use all the different Terraform stages like Terraform init, Terraform format, validate, plan, and apply. And apply will only happen when we merge to master, which is the key, right? You really want the PR to be approved first before applying and making things happen. So, okay. So now what will happen is we'll just create a pull request. And I do not type this fast. I wish I was. I was like that fast of a typer, but I'm not. So you switch back to the repo here, and you create the pull request. Very, very straightforward workflow for an operator. You create the pull request. Immediately, this should fire our GitHub Terraform action. So immediately you see like we have an expected status check, and make sure you do branch protection on these repos so that only approved pull request can get merged in. If you see our change, that's our record that's being added. If you switch back and we open up the details for that Terraform action, we see this is the Terraform validate, init, and plan that's running. I fast forwarded this again. You can see we're adding that one record. And as soon as this thing finishes, you'll notice that the Terraform apply did not run because this is not the master branch. All right, so now we have the GitHub bot that comments in the plan, which is really nice. So you can see the Terraform plan, what's going to happen before it actually happens, see the code change. And if it looks good to, I guess the teammate, they can do a +1. I'm pretty lonely here because this is just my repo, but I'm the only person in the team. It's quite unfortunate, but that's okay. And we'll squash and merge this change in. And remember to do the most important thing, which is to delete the branch right after this. Otherwise, you have these dangling dead branches, right? You don't want that in your repos. And I'm sure your teammates will appreciate that. So now if you go to the commits here, then you'll see the apply actually started running here. We check in the details. We run all the steps again. We run plan again. You don't need to do that. You can just run apply. But in this case, I'm running plan, and then wait for the apply to finish. And what we can do is we can actually see this is getting triggered in Terraform Cloud as well. So you don't have to use Terraform Cloud. In this example, I'm using Terraform Cloud. It's fairly easy for me to set it up. This is kind of my on-prem for me. So in this case, it's running Terraform apply. As soon as this thing finishes, it takes about a minute or so. I'm fast forwarded this for time's sake. We can go back to our master branch and make sure the checks have passed. And you'll see there's a green tick mark. That means our apply successfully finished. We go back to Cloudflare. We refresh our DNS provider, and we see a subdomain entry pointing to the www.buycoffee.app domain, which is again proxied through Cloudflare, which is awesome. And if I refresh here, we see that this is working, and I can order more coffees, more and more coffees, keep placing those orders. I'm sure someone's going to break this. I'm really bad at UI and UX design, so this is the best I could come up with. But I hope this works. So if you go to any other page for that application, you'll see there's a 404 page, right? Like this is a basic S3 page. You don't really want that. Let's say a developer wants to change the 404 page, right? So they can easily add another object, and they don't have to use the clone the repo and stuff like that. You can do this using the GitHub UI, but in this case, I'm actually showing you the full end-to-end workflow here. So here I just define and replace index and use the error.html file. Fairly straightforward. Nothing complicated. Again, I check out a new branch and create a new pull request. Okay, so this is how I type. This is how slow it is. And I do a lot of mistakes as well, as you can see right there. This is my normal speed. Okay, so I can push this branch up to upstream, go back to my repo, and we create the pull request. Create the pull request. Hit the create the pull request button here. And then that'll fire off the GitHub action. Again, same workflow for the developers as well. As you notice, same repo in this case. You can have multiple repos. That's all right. You can wait for this check to pass. And what can happen is a lot of times things don't go exactly right. Things are invalid sometimes. In this case, the validate command failed. And we want to see why it failed, right? We want to see the check has failed. We can't merge this. So let's go back and see that. So when we see the logs, we see there's a duplicate name for the object, the S3 bucket object. So you can easily fix that. Developers don't have to clone the repo again. It's all in one context. You have just the pull request, you just edit this file right here, and you fix the error, which is a simple typo of the copy pasting errors that we all have had in our lifetime. So we fix that by just changing it, making it unique. I'll just call it error, commit to the same branch. It re-triggers the GitHub action again, hopefully. You scroll back. Yeah, immediately the action goes. And if it's successful, you'll see a valid plan in the pull request. And this is fairly easy. Again, the same workflow for developers and operators. You see right there's the plan. You can see the plan right there. What's going to happen before it actually happens? The operations folks look at that. They look at the file change. They say it's a fairly small change, very safe to do. They can give us a thumbs up. So right there, thumbs up. And you squash and merge it. remember to delete the branch. Go back to the repo. We'll wait for the apply to finish here. I've fast forwarded this, so it finishes quite quickly here. And we scroll back right there. We refresh this page. You can see the error page right there, which is perfect, which is what you want to see. So that was a quick demo of using the thing end to end for developers and operators. Now, that might be maybe a bit too much. You can actually immediately use a starter workflow that's available. You just go to your Actions tab. You'll find the setup Terraform CLI featured there. You can just click that, and it'll just set you up to on your infrastructure journey and let us know what you think. In terms of highlights, like the actual GitHub Action 1.0, you know, the new version is actually available on the GitHub Marketplace. You can search for it, or you can go to this URL, which is git.io, Terraform GitHub Actions, and you can find the demo and my slides. They're already open sourced. You can find them at git.io, Terraform GitHub Satellite Demo. And if you want to learn more about how GitHub and HashiCorp are working together in terms of products and what our vision is, we have a white paper that's available. It's called Increasing Developer Velocity in the Cloud Operating Model. And I really, really appreciate having me. Thank you. If you have any questions, I'm in the GitHub discussions, or you can DM me. My DMs are open. My Twitter handle is build 1.0. Thank you so much.
Thank you so much, Mishra, for that fantastic presentation. It's really, really cool to see how the integration of GitHub Actions is happening with so many cool things. Now, before we jump into questions, we've got a fourth person on the screen. Welcome to John, one of our own from GitHub. He is an expert in GitHub Actions, and we're very excited to have John here answering all the amazing questions that are coming in about GitHub Actions. So we have time for a couple of questions. Jared, you've been on the discussions. Before you hit me with the question, tell me what your favorite part of the talk was.
Honestly, my mind's still kind of blown. So, Mishra, you're a podcaster, you're a DJ, you're a maintainer, you're a technical advisor. Like, what have you not done? Like, the beginning of your talk just made me feel lazy. Like,
I'm not the best. I'm not the best at cutting vegetables, actually. Like, that's one of my struggles so far, I think.
that is a random thing to not be good at. I think if I could be good at all the other things and not be able to cut vegetables, I would take that as a win. Just putting it out there.
Yeah, I cut vegetables. Okay. All right, it's okay. I figure with the other things you do, you're probably doing pretty awesome. But enough of my questions. Let's get into the discussion questions. So first one, how can folks get started with Terraform GitHub Actions?
John, you want to take this one?
Yeah, sure. So we've provided a starter workflow that's now available from the Actions tab of any repository that you own. You head there and you see the Terraform starter workflow. So this just recommends a way to get started with them. And of course, you can edit that and change it as you need to. But we think that's a good place to get started.
Outstanding. All right, we have another question coming in, and it is from @IGPacker. @IGPacker wants to know, is there a way to analyze the plan in the master branch before applying?
Yeah, so that's what ends up happening in the actual workflow, actually. So you're able to run the plan in the pull request before it actually merges in, and that'll show you, like, you can actually get it commented in. In my demo, I've shown how you're able to just use another action, which basically does a create comment. You can take the output from the Terraform plan, pass it to that action. That action should be able to create the comment. So you're able to kind of preview what's going to happen. And then you can add your own actions. Like, you can do many things with the plan if you like. So like the plan output in our case is something that's human readable, but you also have a JSON option. So you can actually like dump it as a JSON file, and you can analyze and do things with it. And you can write anything you want. Actions just allows you to do pretty much anything you want. This is pretty awesome to have this like really like amazing flexibility, and pretty much everything runs in parallel. So it like saves you time. It probably wouldn't be that time consuming if you're not doing something crazy.
I think that's like awesome. One of my favorite things about actions is that, like, if something doesn't exist, you can like essentially just build an action to like just make it happen. And it's just so cool. I was like, I'm so glad we added in this feature. It's just amazing. Just gives developers like all the powers to do all the things. Now, Jared, do we have any more questions coming through? I think we have a couple.
You know we do. Oh, we have a couple more coming.
yeah.
I think something
Get 'em
awesome about
all.
Actions. I'm going to try and get as many as we can. We don't have all the time in the world, but I think something about Actions is you were mentioning it before, Mishra. I mean, Actions has been out for a couple of years now, and now it is the most popular CI possible. So I think it's amazing what people are able to do with Actions, and I'm so happy to see what HashiCorp has done as well. Now, enough about me. I keep talking too much. We have another question coming in, and this is from @RKZM. Interested, he is or she is, or this wonderful person is interested in seeing how we can drive test infrastructure using Terraform Packer and GitHub Actions.
Cool. This is an interesting one. So yeah, so I have some comments here. So I actually, prior to joining HashiCorp, like I was already a Packer user. So Packer is our tool that helps you create server images. And this was one of the first blog posts that I've ever written online, I think, which basically uses Packer and Server Spec, which is another open source project, amazing project. You can use them hand in hand and kind of validate Packer images as well. So you can actually write an action that does that for you. And you can actually use Terraform to spin off infrastructure that's kind of test infrastructure. And basically, let's say you have an image that you just build using Packer, and it's like Ubuntu 16.04 for your web server or something like that. You use the GitHub action to trigger Terraform to create you that infrastructure. That can actually run your server spec tests and then provide the output again. Based on that, you can fail or pass the pull request. So you do all kinds of like interesting things with just this amazing open source ecosystem. It's very pluggable, so it's fairly easy to do.
That's pretty sweet. I think that actually leads in to the next question we're actually going to have somewhat. So this is the next question is from @Shivya Does it work for all cloud platforms like Azure and GCP, Google Cloud Platform?
Yeah, so actually, most of our products, like pretty much all our products at HashiCorp, we're a very cloud agnostic company. So we launched Terraform when it was, I don't know how many years ago, but it was already, basically cloud agnostic. You could use AWS, you could use Azure, you can use GCP, you can use Alibaba Cloud. There's 200 plus providers. So if you go down the list, there's pretty much all your happening cloud providers. You have the small cloud providers as well. DigitalOcean, things like that. So you can use pretty much anything that has a CRUD API. And if there isn't one, you can just write a provider, which is very easy to plug in to Terraform as well. Very easy to write a provider. There's a full documentation and guides on our Learn websites, learn.hashicorp.com, that you can follow and kind of go with that process.
Outstanding. I think, Mish, do we have time for one more question? Do we have one more?
If it's a very quick answer, we've got about 30 seconds, so go for it.
Okay. Quick question from D Greenfield 0. Do actions integrate with Terraform destroy and other management commands?
Yes,
they do.
That's absolutely correct. Yeah, John, you want to take this?
Yeah, sure. So this is a wrapper on the Terraform CLI, which you're probably already used to, and all the CLI verbs are supported in this v1.0 action.
Awesome.
Outstanding.
Nailed the question with like 5 seconds to go. Love it. Thank you so much, John and Mishra, for joining us. Now, I know Mishra is going to be over in the discussions for the next half an hour. John, will you be joining him?
I'll be there. See you there.
Awesome. Both John and Mishra will be there. Catch them over in the discussions. Thank you again both for joining us. And we'll catch you next time. Bye.
Bye-bye.
Bye.